Hi there, and welcome to another Papetti Math YouTube video tutorial where I'm going to be teaching you, yes you, Algebra 1. And in this video, we are going to sum up our Chapter 3 on lines and linear equations with some linear inequalities, where we're going to be looking at word problems that involve linear inequalities, making sense of them, and then graphing the situation that they represent. So it says up in the top right here, graphs are often used in the real world to illustrate data and statistics in a user-friendly way. Graphs of linear inequalities are useful because they show all of the possibilities with a given scenario. It will be up to you to determine appropriate solutions based on the context of the problem. Appropriate solutions is our keyword there because remember, in real life problems, we want real life answers. So let's take a look at exercise number 1 that has to do with a farmer in upstate New York that has cattle and horses. Each cow eats 20 pounds of food per week, and each horse eats 30 pounds of food per week. If the farmer can afford to buy 210 pounds of food each week, set up and graph an inequality representing all of the possible combinations of cattle, X, and horses, Y, the farmer can own. So let's begin by setting up an inequality, and we'll see that we're going to use X for cattle and Y for horses. So what information do we know? So let's go back in this problem and see that we know that each cow eats 20 pounds of food per week. So if the number of cows represent X and each cow eats 20 pounds of food per week, we have 20X represents 20 pounds of food per cattle per week. And now we're not only dealing with cattle, we're also dealing with horses. And we know that each horse eats 30 pounds of food per week. So we're going to add to that 30, and it says to represent horses with Y, 30Y. So this says 20 pounds of food per cattle per week plus 30 pounds of food per horse per week is, then we have this 210. So now we have to do something with this 210. And the farmer can afford to buy 210 pounds of food each week. Does that mean he's going to buy 210 pounds of food per week? And the answer is no, because if he only has one cow or one horse, he's not going to buy a surplus of food because that food's going to go to waste. So if he can afford to buy that, that means the very most he could buy is 210 pounds of food. Everything else has to be less than or equal to that 210 pounds. So we're going to go ahead and we're going to graph this on this set of axes. But wait, because we're not used to graphing something that looks like this. So we need to do something with this inequality to make it more friendly to us. And the thing that we're going to do to that inequality is we're going to isolate y, and we're going to put this inequality in mx plus b form. So let's go ahead and let's start off by subtracting 20x from both sides. And we'll be left with 30y is less than or equal to, and I'm going to put my x's first, so I have negative 20x plus 210 to preserve that mx plus b form. And now my final step to get y by itself is I'm going to divide everything by 30 over here, and I'm going to be left with y is less than or equal to negative 20x divided by 30 will simplify to negative 2 over 3x. And 210 divided by 30 will give me a positive 7. So now I'm ready to graph this. And when I graph this over here, I'm going to be graphing on this coordinate axis. Here we go. I'll move myself over here. There we go. Bye-bye. All right. Now, I need to graph this inequality over here. So again, we start off by graphing our y-intercept of 7. And we know our slope is negative 2, which means down 2, right 3. We're going to go down 2 more and right 3 more, down 2 more and right 3 more, and that's all the points that fit on my coordinate plane. So I'm going to connect those now. So remember, if I have that equal to sign, that means I'm going to graph an equal to line, which means it's a solid line. Solid line underneath the inequality means to graph my points with a solid line throughout. Okay, and I could do a better job of that, and I'll do that. So I'll go here, I'll get a nice straight line to go through those points. There we go. Okay, And now that I have my solid line going through those points, I need to shade this graph. Notice how I did not put arrows on this graph. And if I were to put arrows on this graph, it would show that it's possible to have solutions that are negative horses and negative cattle. And that's not possible. So that's one of the things that was being talked about in this part of the directions where it says appropriate solutions. It's not appropriate to have negative horses or negative cattle, so we don't put arrows on that line. But we do want to know where that line is less than or equal to. So where the y value is going to be less than this line. So again, I look at my y-intercept, and they're going to be less than that line going downward. So I'm going to shade this graph downward because y is going to be less than. And where I'm shading is all of the possible solutions that this farmer can afford to have with cattle and horses in order to be able to feed them all in a reasonable way. So any point you see in this solution set is what the farmer could have. So he could have two, let's remember what x was equal to, cattle, and y was horses. So he could have 2 cattle and 3 horses. He could have 5 cattle and 1 horse. He could have 7 cattle and 0 horses. Could he have 9 cattle and 1 horse? And the answer is yes, he can, because we are on a solid line here, which means it includes the points that are on the line. So it is possible for this farmer to have 9 cattle and 1 horse, because he will be able to afford to buy that 210 pounds of food per week to feed them. But the reason why a graph is useful is because otherwise you're substituting every possible number into this inequality to see if it works. For example, we could just go to 4 cattle and 7 horses, and you could see plain as day that that point is outside the inequality. He's not allowed, or she is not allowed, to have 4 cattle and 7 horses. The farmer will not be able to feed 4 cattle and 7 horses with the amount of food he's able to buy per week. So one of the useful applications of using a linear inequality in real life. If this video was helpful, please give it a thumbs up, and you're ready for exercise number 2 now, right here in the link provided.